Hey guys, welcome to a new tutorial series today, and this is going to be a beginner C# series taking you from very start of not knowing anything about C# and getting you up to speed with being able to add basic mechanics, understand the fundamentals, being able to write your own lines and then take it from there. I mean, I did do a tutorial a few years ago now on the basics of C#, but I had some feedback on it and I thought that I would bring it up to, even though the concepts are still the same, bring it up to the year of 2019 as we are now and beyond, and have something that you can really look at and just have classic examples of how you can incorporate good features into your game. So if you're familiar, it's not going to be a crash course in exactly Unity. I will go through some Unity things if that's what people are interested in, but it's going to be more along the lines of getting to grips with core features and mechanics, and I'll show you step by step. So this is the start, and this is the basic project that I'm going to start it with. It's based on Unity's sort of rollerball tutorial series, but I'll use this as an example because I quite like the cool sort of neon look, and we'll add features to this so you can see examples of gameplay and how to add these yourself. So how I always like to start is that some people and a lot of people will look at C# and think, how do I even start? What do I even do? And where can I go? Now, there's one thing that you can always do is you can go to help in Unity and go to the scripting reference, and you can often search in scripting and search for things that you might want. You can search for code snippets on Google. You can search for specific questions that you might have, like how do I move my player, or how do I interact with a box, or how do I make a box turn itself off? And that's the basic first steps of how to do anything. Even if you're the most advanced programmer ever, you still go to Google and Google lots of things and look at the scripting reference and think, oh, look at these examples, and go from there. But because it's your first day or your first time that you're going to be looking at it, if it is, when you're inside of Unity and you've got your scene open, there's a few ways that you can start your own script. You can select the player, and you can go to the bottom of my player here and add a component. And we can choose to add a new script if we chose to do it on this object. We could write the name, choose the language, which would be C#, and just click create and add. That's fair enough. Or we can go into our project panel, wherever your project panel might be. Mine's just at the bottom here. You can right click, press create, and choose C#. So that's what we'll do. We'll start a C# sort of script. And what we can do is we can, as is classic to programming, we can call this script Hello World. You can call it whatever you want. The class will be named the same as the script, so always be sure to keep this name the same. And then what you can do is you can open up in Visual Studio. And usually when you open up Visual Studio, you can see a few things going on, and it might look a little bit strange, but these are the things that will go on day to day. Now at the top you get a set of collections and you get a set of instructions which allow you to use specific features inside of Unity for various different reasons. Now you can often tell when specific collections are being used because it'll look slightly greyed out or lit up if you're able to use the specific Unity features. There is a lot more collections that you can use. And sometimes if you buy your own assets, you can use your own. Let's say, let me give you an example of Unity using Unity Engine .ui. It's usually along the lines of specifying Unity Engine and putting a dot and then a specific feature that you want to use within Unity, because you can access the UI features in Unity for the user interface stuff, where if you want to select and maybe edit images on the UIs or text components on UIs, you need to be able to access it here. But I'll go into it in the future, but this is just something to be aware of. You get a public class definition, and this is a name of your script. You can obviously change this, but you want to make sure that your name of your script is changed as well. It's a mono behavior script, and it just means it derives from this class. Then you have a bunch of curly brackets. I like to call them curly brackets. I mean, I know people like to call them parentheses and things like that, but for me, a curly bracket is, as it suggests, it looks a little bit strangely wiggly curly, and these are just normal brackets to me. So that's how I'll say it in this series. So what I like to do usually when I start any script is that I like to just knock the curly brackets down, because there's two sort of ways that people can often if I get rid of just these two ways people can often write the code, you can have your method definition up here, and we'll go along with it as we do. And with the method definition, you can keep this curly bracket along the top here. Some people like to do it like this, let's say, and then you can write your code in here however you want, like so. But if you're like me, and for some reason, you know, there's a big argument and a big debate on the internet as to what is better, I like to knock them down like that because, I mean, it's just like a little OCD for me and it feels much better. So I have everything underneath each other, and it depends which way you want to do it, but it makes no difference either way, whether you have it like I said or whether you have it just like that. Makes no difference, it's just the style of the syntax really. Okay, so what I like to do when we start off, so we've got that together, you will always in your class have one left facing curly bracket and one right facing curly bracket, and you will have all your methods, statements and information within those two, which will be encapsulated by that class specifically. Now, in a C# script, you will often have your variable definitions at the top of the script. And variables are often information that you want to save or you want to be able to pass to your specific methods or things like that. So you can give numbers or store game objects or things that you will actually do within your game. So how we start by writing that specifically is we can write a definition of a variable as public or exactly as private. And what these mean is that a public variable is something that can be seen everywhere, not just classified to this script, because if it's public, it'll be accessible in other scripts. If you need to, you create a health manager and you want to be able to edit the health from another script, you need to make sure that your variables might be public to change that health. Whereas a private is private to this script alone, which means you will only ever be able to edit it within this script, so you won't be able to access it from anything else. It's good to keep your variables private where it's important to be private. Don't keep everything public because then it'll just start getting confusing, and it's just better programming practice to have everything that should be kept to one script alone private, and only when you need to have it as public. Now, what we can do is when we have different variables, we need a type of the variable. So if we have a public variable, what can we do? We can have various types of a variable. So the most common things that you will find in programming is an integer, which is a solid number value. So that can just be, we can just give that a name of number. You will always give whether it's public or private first, then the actual type, then you will give the name, which can be anything. Then with this we could have public float and have it as number float. A float is a number with a decimal place. There is other types of numbers, like you could have double or something like that, which is double precision accuracy for variables, but most commonly it's integer, which is a whole number, and float, which has decimal places. And it's good when you're writing your code in C# or anything like that, your first word in your variable, or the first word in your variable name, will be lowercase, and then everything after will have an uppercase. It's just something that people tend to do when programming, so you don't get confused with because you might have a method which you might write down here which has a capital, and you don't want to get confused between what is a variable and what is something else. So what else can we have? We could have public game object, and we could name this player, and game object is a reference to letting us add a game object in the inspector within Unity, and allowing you to add a game object, and you can access components on that. So if your game object might be your player, and your player has loads of scripts on it and components which have maybe a rigid body for physics, might have a health controller, it might have a damage script on it, you can access those things directly, usually with game object, or you use game object if you want to turn the entire object on and off. It just depends what you're going to do with programming, but we'll go through it as we go along. Another good example would be public bool as, we'll say, true or false, and bool is another one, which is a very common one as it's 1 or 0 or true or false. So it's good for checking for certain things that you might want to check if your player has died, for instance. Has it died? Is it true? If it's true, then what could we do with that? We could do something with that. So that's all well and good. And if I give this example, we can get rid of the private now. If I go into Unity, let's say now, I can right click my hierarchy, add an empty game object just for the sake of this, add my script to it, and you can see here that I've got number float, player, and true or false. You can see that if I go up and down with this value, I can choose solid numbers. If I go up and down with this other value, it's a decimal place value. If you can see that there's a place for a game object, I could realistically add my player to that. And a true or false is a tick box saying true or false. So these are just some variables that we would commonly use day to day. But one thing to remember is if we've got a public variable, we can see these in the inspector here because they're visible. If you make something private, let's say like this, you don't have to specify a variable as private like that. If you specify a variable without the definition of whether it's private or public, it will be private. It's just something that whether you want to shorthand it or whether you want to be specific about it and give it the exact name, it's up to you, because it can be something that if you want to read back, you might want to just keep everything very standardized so you know exactly what's going on. Now you can see that numbers disappeared because it's private, and you might think to yourself, well, I wanted to see the number in the inspector, but I didn't want other scripts to be able to access it. So this is not a particularly advanced feature, but it's something good to know from the very beginning because I didn't know it for a long time. Now, Unity has some special things called attributes, and attributes are things which you could specify, which do small things for the inspector, which allow you to have different functionality to be able to get the most out of the things that you do. So you often put square brackets, and you can write serialize field in here in front of square brackets in front of your variable definition, and that private number, that private integer that we created, will now be visible in the inspector, but it will still be a private variable. So it's still only accessible to this script, but means you will only have to, if I copy this and let's say get rid of all the publics, and we just do it like so, they're all private now, all secure, so nobody can access it. If you're making a game which is, visible to the public, or say a multiplayer game or something like that, and you keep things protected, they won't be able to access it so easily. You can then go back into Unity, and you can see that once my variables refresh, now I can see them all again in the inspector, but they're private still, which is really helpful. So you've got to remember that when you're doing your variables, you can have them as public or private. You can use the square brackets serialize field, which just means it serializes it so it'll be able to be seen in the inspector. You can classify your variables as different types. There is more types which you can look at, and then you can give it any name you desire. And that's the basics for adding variables to something. Now in your script, if you're thinking, oh wow, what do I do now? I've got some variables, now what? Well, what you can have is that you can start by writing your own methods, or methods that are defined in Unity to do a specific purpose. So the most common ones that you'll find, or the most common two you'll find, is void start, and when you're in C# and you usually press tab, it will auto-complete it for you. Similar with how variables are defined, private void start is just a private method. Just as you could with a variable, we can make it so this method is public, so then we could potentially access it elsewhere. But if you didn't have the private definition, just like that, it would be a private method to this script alone, so nobody else can see it. No other script can see it. So you always start by writing void, and void just means it doesn't return anything. And then we specify start with a capital, and start means it's a method which runs as soon as the game starts. And then what you can do is you have two brackets which face each other to end it, because you can eventually in the future write parameters into there, but it's not something that we're concerned about at the moment. And just like with the original curly braces that we had at the top, you have a left and a right facing curly bracket. We could write, for instance, debug.log open brackets in quotes, and we can say hello world, because that's what we wanted to do in our first script, didn't we? So, because that's very famous. So what this means is as soon as the game runs, within our two curly brackets, this is something that just outputs to the console in Unity. Debug.log is just a debug output. We have a set of brackets and we put quotes because we're outputting a string value, and for every statement that you add to Unity, which is a statement which is not say something like an if statement or something specific to needing other functionality or other logic with it, it will always need a semicolon on the end, because that's just how we end basic statements in C#. Now, another example is that, say, we have void update, and the same again, if when I press space, when I start writing it, auto completes it for me because it knows what I want to write. So update is something that's executed when you have your code there. I'll give you another example. Debug.log open brackets, and then we'll say I am here with a semicolon. And what this means is that update, or the update function, is something that's run every single frame. So if you've got 30 frames in your game, it'll be run 30 times in a second, 60 frames, 60 times in a second. So you don't always want to throw all of your logic into the update method if you can help it, because if it's run 30 times every second and you have an awful lot of code in there that you don't need, it's going to get bogged down and slow your game. So it's about learning little things as you go along, but it's about you getting your head around the basics at the moment. For start is good for as soon as your game starts. Do you need to set values to a particular value? Do you need to find some game objects? Do you need to do some basic logic as soon as the game starts and use it from there? And then update, do you need to check something all of the time? So do you need to check whether the player is using a controller? Are they pressing a particular button? Because you want to always be checking for input. So is somebody always pressing the keyboard? And if they are, you want to say, yeah, okay, it's checking 30 times every second, so the person is pressing W, so we need to execute that code if we specify it. And as a pure example for this, we can write our own custom methods, which are different to the ones built into Unity. So we could write private void, and we can name it whatever we want. We could literally name this just like this, the hello world method, and then we can add one left, one right curly bracket, and then what we can say is debug.log in quotes, and then we can say my custom method. But you've got to also remember that you can't have a method name the same as your class name, so we could just call this hello world method, for instance. So that's perfectly fine. This will only get called, like we said, start gets called at the beginning, update gets called all the time, but your custom method will only ever execute when you tell it to do it. So it could be something that we do at the start. We could say, all we do is we write hello world method, just as we might expect, the two brackets facing each other, and add a semicolon. So we're writing a statement and we're just saying when the game starts we expect hello world to be output, then we expect hello world method to run, because we're just saying come on, do whatever you need to do. Then we expect my custom method to appear in the console, but then all that time in the update function it will be outputting I am here a lot of the time. So we'll give this an example. So you can see down here in my console, I won't maximize on play just so you can see what's happening. We can press play, and you'll notice that as I'm trying to keep up with it, we started at hello world, my custom method, and then I am here, and you can see update is running all of the time, and we're getting more and more notifications that it keeps posting these values to the console all the time because we're telling it in the update function to keep on putting that debug. This isn't very refined because I wouldn't do that all the time because you don't need to. But as you could see, when I clear it, it's still going, and you could see that start, it outputted hello world like we expected. We called the method here, which we made, and we outputted my custom method. And then all the time that was going on, then the update function was spitting out every time, I am here, I am here, I am here, until we tell it to do otherwise, until we tell it to do something else. So this was just the basics of getting to grips with C# or your first script and understanding how it's set up, how to make one, how to define your variables, and the basics of looking at your first methods, what basic methods do, and what basic lines of code and how to structure the syntax in the statements that you write. But I'll be going along and helping you along the way, and we'll add cool mechanics to our little ball game, and then you can see how it goes from there. And please let me know what you think of this. Thanks very much for watching. Don't forget to like, comment and subscribe. Cheers.